Hi, third graders. Yesterday we learned how to solve multiplication problems using arrays and tape diagrams. I'll do a quick review right now, but it might be worth rewatching the video from yesterday and going through that completely before we move on to our new lesson. But just to review, yesterday we talked about taking two factors, for example, 3 times 7, and using arrays and tape diagrams to figure out the fact that 3 times 7 is 21. In this first picture, this is our first model. This was our array. We knew that our first factor was 3, which means 3 groups, so we made 3 rows and we put 7 in each row. We were able to prove then that 3 rows of 7, or 3 equal groups of 7, does make 21. We talked about how you can use the commutative property to flop those factors. So instead of 3 groups of 7, you can do 7 groups of 3, 7 groups of 3, and 7 groups of 3 is also going to be 21. In the second step, we used a tape diagram to solve the exact same equation. So we knew we needed 3 groups or 3 parts, and each part was going to have 7. So we made a tape diagram, we divided that into 3 equal parts, and we put 7 in each part. Therefore, once again, we have 3 groups of 7. And when we combine those 3 groups of 7, 7, 14, and 21, our whole 3 groups of 7 is 21. Likewise, we can use the commutative property on this one as well. Instead of 3 groups of 7, we could turn those factors around and get 7 groups of 3 for 21, and that's what we did here. We have 7 groups of 3, and we skip counted on this one. We just skip counted by 3 7 times. 3, 6, 9, 12, 15, 18, and 21. Today, we're moving on. We know that we can solve multiplication problems using arrays and tape diagrams, but today we're going to move on and add in division problems. So I can solve multiplication and, here's the new part, division problems using arrays and tape diagrams. Vocabulary for today. When we're dividing into equal groups or equal parts. The dividend is the amount that we're dividing. For example, if we go back to our numbers from yesterday, if we have 21 of something, and we'll put a label with that in a minute, we'll have 21 of something. So we have 21. That number is our dividend. That's the total number that we have, and we're going to divide that total number into equal groups. The number of equal groups that we have is going to be called the divisor. So 21 is our dividend. We're going to divide 21 into 7 equal groups. 21 divided into 7 equal groups. And this is called our divisor. That's the number of equal groups that we have. And the answer then, 21 divided into 7 equal groups, the number that's going to be in each group is going to be our answer. It's also called our quotient. So today our missing number is going to be our quotient, and this will be our missing number. So sticking with the same numbers as yesterday, starting with 21. Oh, let's see. Let's put a label on this one before we get started. I would say if Alexis was here, she would tell me to divide 21 puppies or kittens into equal groups. Carson would tell me to divide 21 books into equal groups. Okay, if it was Jace would ask me to divide 21 birds into equal groups. But I think I'll go with Alexis. Let's say that we have 21 we'll go puppies today. So if we had 21 puppies, and we were going to divide those into 7 equal groups. We have 7 families or 7 homes that want to share those puppies equally. How many puppies would each person get? So 21 divided by 7 equals what? First thing we're going to do is tackle that array. An array is a model that we can use to solve the division problem. Only we're going to be starting with 21 altogether, and we know that we want to divide it into 7 equal groups. So we have 7 parts or 7 groups. So today, using the array, I'm going to start with group 1. Remember, we have 7 groups. So here's group 1, here's group 2, group 3, 4, 5, 6, and 7. We're going to have 7 equal groups. We don't know how many are going to be in each group. We just know that we have 7 at this point. I'll section those off so you can see them just a little bit better. We have 21 kittens, or did we say puppies? I think we said oh boy. I think we said puppies, so we're going to go puppies. So we have 21 puppies in 7 groups. So we already have 1 puppy here, and we have 1 puppy here, And so we're just going to go ahead and keep doing that until we get rid of those 21 puppies. So right now, 7 families each have 1 puppy. So I have 1, 2, 3, 4, 5, 6, 7 puppies given away. This would be 8, and I'm going to give everybody one until I run out. 9, 10, 11, 12, 13, 14. Keep going until I get 21. 15, 16, 17, 18, 19, 20, and 21. I gave away 21 puppies, and I shared those into 7 families or 7 equal groups. Let's find out how many puppies each family gets. Well, this family gets 3. This family gets 3. We know in division, everybody's going to get the same amount. So each family is going to get how many puppies, everybody? 3 puppies. So 21 divided by 7 equals 3. We can also use the commutative property on this one as well, although we'll start with 21 puppies. But to use the commutative property to be able to switch those numbers around, we're actually going to have to go 21 divided by 3. It means something a little bit different. 21 divided into 3 equal groups is what? So this time it changes the story a little bit. This time we have 20 puppies, and we're only sharing those puppies into 3 groups or 3 families. So 21 divided by 3 if we use the commutative property. 21 divided by 3 means how many groups do I have in my array, everybody? 3 groups. We do the same thing as we did before, only with 3 groups instead of 7, since we used the commutative property on that one. So now we have 3 groups. And how many puppies are going to be in each group? I bet you already know, but let's see if we can prove it. We've given away 1, 2, we've got 3 groups, and we have 21 puppies to give away. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I gave away 21 puppies. I put those into 3 equal groups. So 21 divided by 3, and let's see how many everybody gets. 1, 2, 3, 4, 5, 6, and 7. And sure enough, if we just count by 7s, there's skip counting, 7, 14, 21. Everybody gets 7, and we gave away a grand total of 21. So 3 groups of 7 make 21. We're going to go ahead and move into tape diagrams. You can use tape diagrams to solve a division problem as well. We're going to need to go back to the original problem. We have 21, and we want to divide 21 into 7 groups. So for my tape diagram, I'm going to need 7 groups or 7 parts. Okay, I know you're really good at this. I need 7 parts in my tape diagram. Everybody, how many lines do I draw to make 7 groups? I know you said 6. 1, 2, 3, 4, 5, and 6. Sure enough, if I draw 6 lines, I'm going to get 7 groups. And I have 21 of those puppies to give away. So here we go. Remember this, each one is a unit. Each one is a group. There we go. We have 7 of those. All right. And I have 21 puppies to give away. So I'm going to give everybody one until I run out. And I have 21 altogether. So here we go. 1, 2, 3, 4, 5, 6, and 7. Keep going. 8, 9, 10, 11, 12, 13, and 14. Keep going. I'm going to 21. 15, 16, 17, 18, 19, 20, and 21. So let's see if we can get this figured out. We have 7 groups of how many in each group? Say it. 3. 3 here. You got it. Each family or each group is going to get 3. So we have 7 groups of 3. So coming right back up here, we started with 21. We divided that into 7 equal parts on our tape diagram, and each part got 3. 21 divided by 7 equals 3. Once again, commutative property is going to work, but we would have to change our problem a bit, our story problem a bit, because this time we'd have 21 puppies divided into 3 equal groups or given away to 3 equal families, and how many would they each get? So 21 divided by 3 using a tape diagram. Here we go. Now this time we only need 3 equal groups or 3 parts. So how many lines? 2, of course. There we go, part 1, part 2, and part 3. We're going to do the same thing. We're going to take 21 and we're going to divide that into equal groups. So starting with 1, 2, 3, I'll keep going, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Once I get to 21, I stop. That's how many I had to give away. I have 3 groups of 1, 2, 3, 4, 5, 6, and 7. So 3 groups of 7. And we can just quickly put those back together. 7, 14, 21, counting by 7s there on that one. So we now can see that we can use tape diagrams and arrays to solve both multiplication and division problems. I would urge you to practice using multiplication and division equations and then the pictures to solve. Do a few on your own and let me know how it goes. And that's it for today.